All right, so again, we're just going to look at what a slope is, how it's used. Okay, so in this first example right here is a good way that slopes and looking at rate of change is used in daily life for cities, especially for, in this case, Manhattan of New York. So below is the graph of the population of Manhattan Island, and this is part of New York City in New York every 10 years from 1790 to 1990. Coordinates of some of the points are shown. All right, so the coordinates that are shown is definitely this point right here, this point, this point, this point, this point, and this point right here. So they didn't show all the points, but they showed some. All right, so what we've known from the last notes is from left to right. All right, that's as we read the graph from left to right. If it's going up, it's positive. From left to right, if it's going down, it's negative. So what I want us to do is just kind of highlight parts that are going up. So let's say our up is going to be blue. All right, these are my positives. So make sure you got a highlighter. So we'll go positive slopes, which is the positive rate of change over time. And in this case, what is the time? Look at it. Look at our graph there. What's the time? Is it minutes? No. No, as you look right there, you're at the bottom. There's our key. Our time is years. So we're talking about a rate of change over years, and in this case, 10 years. So every 10 years, how does this population change? All right? So, and then in red, let us highlight that and call that our negative rate of change, our negative slope. Slope is our rate of change over time. So how is our population changing over 10 years? So let's start from the bottom. As I look from the bottom here, from left to right, the line is going slanting upward. So we have a positive rate of change because the line's slanting upward. So over time, our population is growing. All right? And we can find the actual rate of change with these 2 points. All right? So if I take this point with this point, these two numbers right here, this one and this one, we should probably get a positive rate of change between those. All right? But now, for some reason, in the 1900s, something started to happen, right? The population is starting to slant down. The graph is slanting down, so the population is dropping over time. That drop in population is my slope over time. So the drop of population over years, that's my rate of change. So right here, I have a drop, a decrease in population over years, right? So a change in time over years. But then something happened again. Seemed to be a little growth spurt, right? A little growth spurt right there. And then over time, again, the population decreased over time. And that decrease over time is my slope. And in this case, that's a negative slope, right? And then we have an increase. So what scientists would do is they would look at this graph and they said, well, gee, why? What caused this population growth, especially after the 1800s there, especially 1850? What happened? So if you remember your American history and your a little bit of history, you would have learned about the Industrial Revolution, right? So the Industrial Revolution would have created jobs. And where were the jobs? In the city, right? So if the jobs were in the city, people were moving to the city, having kids, having families, and that would have caused the population to grow up. That would be one hypothesis that a scientist would think of y to represent that positive growth. Now, right about the turn of the century, 1900s, the population started decreasing again near the 1920s, and some of that decreased, would have been from World War II, would have been from what happens when cities get too crowded, right? What happens when you're too close to each other and there's nowhere to put the garbage, nowhere to put the poop, nowhere to put the urine and whatnot. So dead bodies, etc., disease, famine, malnutrition, all this stuff would have happened right here to cause a decrease in population. And then scientists maybe perhaps looked right here and said, ooh, maybe this increase started because of the invention of penicillin, right? So people weren't dying from common bacteria. So these graphs give us the data, and then scientists can look at this rate of increase or rate of decrease, these slopes, to determine, what caused it, what happened, what was going on. So it gives us a picture of history, and then we can match different situations with the rate of change. So what you're studying, this slope, is very useful, and what we're going to do in our class is we're going to gather data, and we're going to look at our data and try to determine what it means, what it represents, okay? What's going on? Is it useful? Is it not? Is it helpful? Is it going to help us make a prediction of what might happen in the future? So if we look right here, population is kind of low, but it's increasing. Well, do you think it will steadily increase? Do you think it might drop? Why? Why not? All right, depending on what might be going on, you can make predictions, right? Let's go ahead and read the bottom. The slopes of the lines connecting the points tell how fast the population went up or down. In this chapter, you will study many examples of lines and slopes with this positive or negative rate of change over time. All right, so on the bottom right here, we have a review here. As the slope increases, it's positive, and it looks like an upward slant. The rate of change, if it decreases, goes down, we call that negative, and it has that downward slant. All right, so upward slant, downward slant, horizontal slant. All right. So if the rate of change in a population is positive, does the population increase or decrease? So is our population over here going up with our positive slopes or down? Is it increasing or decreasing? Generally, when you have a positive slope, it's going to be increasing over time. Increasing over time. All right, so at any time you need to rewind or you want to listen to that again, feel free, okay?